Look up at the night sky tonight. What do you see? A vast, glittering canvas of stars, planets, and distant galaxies, but also something far older. The very same constellations that guided ancient sailors, inspired mythic heroes, and shaped civilizations long lost to time. There's a profound connection between the stories whispered around ancient campfires and the data streaming from our most advanced telescopes today. Both are searching for answers to the same eternal questions. Where did we come from? What lies beyond the edge of the known, and how does the cosmos shape not just our world, but our very understanding of existence? This video is an invitation to unravel that connection, to stand at the crossroads where cutting-edge science meets the wisdom of the ancients, where equations and legends weave together into a single, breathtaking tapestry. Think about this. The same stars that ancient cultures worshipped as gods now serve as waypoints for astronomers mapping the birth of the universe. The same celestial events that sparked myths about dragons swallowing the sun are now precise calculations in astrophysics. It's as if humanity has been piecing together a cosmic puzzle for thousands of years, with each generation adding new pieces, some through observation, some through imagination, but all driven by the same insatiable curiosity. What if the tales of creation passed down through generations hold fragments of truth hidden in metaphor? What if modern science is just catching up to insights carved into temple walls or encoded in oral traditions? This journey will take us from the explosive birth of the universe in the Big Bang to the celestial stories of indigenous cultures who saw galaxies long before telescopes existed. We'll explore how ancient astronomers predicted eclipses with stunning accuracy, how mythologies across the world mirror the structure of the cosmos, and why modern researchers are now revisiting these old legends with fresh eyes. By the end, you won't just see the night sky, you'll feel it, as our ancestors did, not just as distant points of light, but as a living story, one that's still being written. So let's begin where all great journeys do, with a single step into the unknown, armed with both the tools of science and the echoes of the past. The cosmos is waiting. The Hindu Rigveda describes the universe emerging from a golden cosmic egg, floating in an infinite void, a description eerily close to our modern understanding of the Big Bang singularity, a point of infinite density before time and space exploded into existence. Halfway across the world, the Maori people of New Zealand speak of Tikor, the nothingness that birthed all things, while the ancient Greeks imagined chaos, a formless void that gave rise to the cosmos. Even the Mayans, in their sacred Popol Vuh, wrote of a primordial sea, dark and swirling before the first dawn, an image that mirrors the quantum foam theorized by physicists today. These aren't just poetic coincidences, they're fragments of a shared human intuition about how the universe began. Consider the Dogon people of Mali, who for centuries have passed down stories of a tiny, dense star at the center of their cosmology, long before telescopes confirmed the existence of white dwarfs and neutron stars. Or the Norse myth of Ginnungagap, the yawning gap between fire and ice where creation sparked, echoing the cosmic inflation theory that describes the rapid expansion of the early universe. These narratives aren't primitive guesses, they're sophisticated attempts to explain the inexplicable using the language of their time. What if these stories weren't just myths but early forms of scientific inquiry, observations passed down through generations? Modern science gives us equations and evidence, while ancient cultures gave us symbols and allegories, but both are grappling with the same fundamental mystery. The Big Bang Theory tells us the universe began as an unfathomably hot, dense point, expanding into the cosmos we know today. The Aboriginal Australians speak of the Dreamtime, a timeless realm where creation unfolded in cycles, not unlike the multiverse theories some physicists now explore. The parallels don't mean ancient people had telescopes or particle accelerators, but they did have something just as powerful: curiosity, imagination, and the night sky as their laboratory. Perhaps the most striking connection lies in the recurring theme of balance, the Chinese concept of yin and yang, the Egyptian duality of mat and isfit, even the modern scientific principle of matter and antimatter, all speak to a universe built on equilibrium. The ancients sensed this harmony just as our equations now describe it, so the next time you hear the story of the cosmic egg or the primordial sea, don't dismiss it as mere legend. It might just be humanity's earliest draft of the greatest story ever told, the story of everything. Imagine tracking the paths of planets without a single lens or digital calculation. Just the naked eye, patient observation, and tools carved from stone or bronze. The Babylonians, over 2,000 years ago, etched their celestial findings onto clay tablets with such precision that their records of Venus's movements still match modern calculations. They noticed patterns in the chaos, turning the sky into a mathematical puzzle. Their secret, meticulous logs kept by temple scribes, who spent generations documenting every shift in the night sky. These weren't just priests, they were early scientists, using rudimentary tools like the gnomon, a simple stick that cast shadows to measure the sun's angle, to predict solstices and eclipses with startling accuracy. Then there's the Antikythera mechanism, a corroded bronze relic pulled from a shipwreck near Greece in the early 20th century. At first glance, it seemed unremarkable, but X-rays later revealed gears and dials so complex, historians called it the world's first analog computer. This device, dating back to around 100 BC, could predict lunar eclipses, track the Olympics' 4-year cycle, and even model the irregular orbit of the moon. Its craftsmanship suggests a level of astronomical understanding we once assumed was impossible for its time. How did ancient Greeks engineer such a marvel? They combined celestial observations with mechanical genius, proving that innovation isn't bound by era, only by imagination. But perhaps the most baffling example comes from the Dogon people of Mali, whose oral traditions described Sirius B, a dense white dwarf star invisible without telescopes, centuries before modern astronomy confirmed its existence. Their legends spoke of a tiny, heavy star orbiting Sirius, a detail so specific it left researchers stunned. Skeptics argue it might be coincidence or later contamination from outsiders, but the Dogon's precise knowledge of Sirius B's 50-year orbital period challenges easy dismissal. Whether through ancestral observation or lost wisdom, their stories hint at a deeper connection to the cosmos than we've yet unraveled. From the shadow clocks of Egypt to the stone observatories of Chichen Itza, ancient cultures turned landmarks into celestial calculators. The Mayans, for instance, aligned their pyramids with Venus's risings, while Stonehenge's stones framed the summer solstice sunrise. These weren't just monuments, they were textbooks in stone, encoding astronomical knowledge into architecture. Without lenses or satellites, these civilizations used the only tools they had: patience, creativity, and an unshakable belief that the sky held answers. Their legacy reminds us that science isn't just about technology, it's about the relentless human urge to look up and wonder. The zodiac we recognize today, those 12 familiar constellations lining the ecliptic, wasn't born from whimsy or superstition, but from meticulous observation. Picture Babylonian astronomers under star-strewn skies 2,500 years ago, charting the sun's path with nothing but patience and clay tablets. They noticed something extraordinary. The sun didn't wander randomly. It moved predictably through specific star groupings, returning to the same points at precise intervals tied to seasons and harvests. So they carved the sky into 12 equal slices, each 30 degrees wide, anchored by the solstices and equinoxes. This wasn't mysticism, it was early celestial cartography, a practical tool for tracking time and navigating an agricultural world. Centuries later, the Greek astronomer Ptolemy formalized this system in his groundbreaking work, the Almagest. But here's what's fascinating. While astrology and astronomy share this common ancestry, they diverged sharply. Astrology wove these constellations into personality traits and fate, but the original Babylonian Zodiac was pure observational science. Take Libra, the scales. Its stars originally formed the claws of neighboring Scorpius. The Babylonians saw balance in its position during the autumnal equinox, when day and night were equal, and so it became a symbol of equilibrium. Even the zodiac's animals and figures weren't arbitrary. They reflected seasonal changes. Taurus the bull heralded spring planting, while Capricorn's goat marked the winter solstice's return of light. Yet modern astronomy reveals an irony. Due to Earth's axial wobble, called precession, the constellations have drifted over millennia. The sun now rises in Pisces during the March equinox, not Aries as it did in Babylonian times, a shift astrology ignores but science quantifies. That doesn't diminish the zodiac's legacy, though. Ancient sky watchers encoded real celestial mechanics into these symbols, long before telescopes revealed galaxies beyond. Their constellations were mnemonics, helping societies remember cosmic rhythms critical for survival. Why does the zodiac still captivate us? Perhaps because it embodies humanity's dual thirst for knowledge and meaning. Science explains planetary motion, but stories like Orion chasing the Pleiades across the sky connect us to the cosmos emotionally. The zodiac isn't just a relic, it's a testament to how we've always sought patterns, both for utility and wonder. Whether you read horoscopes or Hubble data, those 12 signs remind us that every scientific truth begins with a story waiting to be deciphered. Standing at the base of the Great Pyramid of Giza, it's easy to feel dwarfed, not just by its immense stone blocks, but by the sheer precision of its design. This wasn't just a tomb, it was a celestial machine. The pyramid's 4 sides align almost perfectly with the cardinal directions, deviating by less than a fraction of a degree, an accuracy that would challenge modern engineers without satellite technology. But the real marvel lies in its hidden shafts, narrow corridors angling upward from the king's and queen's chambers. For decades, their purpose puzzled archaeologists until researchers realized these weren't random passages. One shaft points directly toward Orion's belt, while another targets the pole star Thuban, which held that position in ancient times. These alignments weren't accidental. They were deliberate, locking the pyramid's interior to the heavens above, as if the pharaoh's journey to the afterlife required a roadmap written in stars. Now cross the Atlantic to Teotihuacan, where the Pyramid of the Sun mirrors this cosmic conversation. Built by a civilization that left no written records, its layout is a mirror of our solar system. The distances between its major structures match the relative spacing of planets, with the pyramid itself representing the Sun. Even more striking is Chichen Itza's El Castillo, where the Mayans engineered a spectacle that still draws crowds today. During the spring and fall equinoxes, sunlight slithers down the pyramid staircase, forming the illusion of a feathered serpent Kukulkan descending to Earth. This wasn't just art, it was a precise solar calendar carved in stone, marking the agricultural cycles that sustained their world. What unites these monuments, separated by oceans and centuries? A universal language of alignment. The pyramids of Giza, Teotihuacan, and Chichen Itza weren't isolated projects, they were part of a global pattern. In Cambodia, Angkor Wat's towers align with the Draco constellation, while China's Xi'an pyramids echo the celestial compass. Even the ziggurats of Mesopotamia, some of humanity's earliest structures, oriented their stairways to Venus's rising points. These cultures had no way to communicate with each other, yet they shared an obsession, anchoring their greatest achievements to the movements of the cosmos. The question isn't just how they achieved such precision, but why. Some researchers argue these alignments served practical purposes: calendars for planting crops or markers for religious festivals. Others see deeper symbolism, suggesting the pyramids acted as portals between earth and sky, where rulers could commune with gods or stars. But perhaps the simplest explanation is the most profound. These civilizations saw no divide between the heavens and their daily lives. To them, the cosmos wasn't distant or abstract. It was a living presence, and their architecture reflected that sacred connection. When we study these monuments today, we're not just analyzing stones, we're decoding humanity's oldest attempt to touch the stars. In the ancient verses of the Rig Veda, written over 3,000 years ago, there's a line that stops modern physicists in their tracks. The infinite was born from the infinite. This isn't just poetry, it's a startling echo of today's multiverse theories. Hindu cosmology, as detailed in texts like the Puranas, doesn't just describe one universe but countless ones, each breathing in and out of existence like waves on a cosmic ocean. These universes, or Brahmandas, are said to emerge from the pores of Mahavishnu, cycling through creation and destruction in spans of time, so vast they make geological epochs seem like blinks. What's uncanny is how closely this mirrors modern physics' bubble universe hypothesis, where new universes constantly bud off from a larger multiverse, each with its own laws of physics. Take the concept of the golden womb mentioned in the Rig Veda, a shimmering, expanding void from which all creation springs. Compare that to Alan Guthr's cosmic inflation theory, which posits that our universe ballooned from a subatomic speck to cosmic scale in less than a trillionth of a second. The Vedic sages didn't have telescopes or particle accelerators, but their descriptions of space stretching, like the skin of a drum, resonate with the language physicists use today. Even the idea of cyclical universes finds a counterpart in Roger Penrose's conformal cyclic cosmology, where one universe's death seeds the next's birth. Are these parallels coincidental, or is there something deeper at play? The Puranas go further, describing layers of reality stacked like lotus petals, some universes dominated by fire, others by water or wind, a metaphor that aligns oddly well with the landscape theory of string theory, where different physical constants create alternate realities. Then there's the Vedic concept of Leela, the divine play where existence is both real and illusory, not unlike the quantum physicist's view of particles existing in probabilities until observed. Even the Upanishad's declaration, as above, so below, mirrors the holographic principle, where the universe's information might be encoded on its boundary. What's most compelling isn't just the similarity of ideas but their purpose. The Vedas weren't trying to be textbooks, they were mapping the ineffable through metaphor. When ancient seers spoke of universes dissolving into pralaya, or cosmic sleep, they were grappling with the same existential questions that keep physicists awake today. Is reality singular or plural? Finite or eternal, science answers with equations, the Vedas with allegory, but both point toward a truth too vast for any one language to contain. This isn't about proving ancient texts correct, but recognizing how humanity's oldest questions continue to shape our newest discoveries. The cosmos, it seems, speaks in riddles that transcend time. Greek myths didn't just name the planets, they mapped the cosmos in stories. Take Apollo, the radiant god who drove his golden chariot across the sky each day. This wasn't mere fantasy, it was a poetic blueprint of the sun's path, a way to explain the unfathomable journey of a star that seemed to rise and vanish without fail. The Greeks didn't know the sun was a ball of plasma, but they understood its rhythm, solstices marked by Apollo's pause at the year's extremes, equinoxes as his chariot balanced the heavens. Even his twin, Artemis, goddess of the moon, mirrored the celestial dance, her silver light waxing and waning in perfect counterpoint to her brother's fire. Their myths weren't just tales, they were oral almanacs encoding the motions of the heavens in drama and divine intrigue. Then there's Orion, the mighty hunter whose boastfulness earned him a place among the stars and a tragic end. His constellation dominates winter skies only to vanish come spring, chased below the horizon by Scorpius, the scorpion sent to punish his arrogance. But look closer, this isn't just a morality tale. The Greeks were tracking Orion's seasonal disappearance, noting how the hunter's stars faded as Scorpius rose. The myth preserved an astronomical truth. The two constellations never share the sky, locked in an eternal celestial chase. Even Orion's belt, those three bright stars, served as a navigational guide for ancient sailors, proving these stories doubled as practical sky maps. But perhaps the most uncanny myth is Phaethons, the reckless son of Helios who lost control of the sun chariot, scorching Earth until Zeus struck him down. Modern scientists hear echoes of solar flares in this tale, sudden, violent outbursts from the sun that could disrupt life below. The Greeks couldn't predict space weather, but they witnessed its effects, auroras painting the sky, crops withering under unusual heat. Phaethon's folly might have been their way of explaining these terrifying anomalies, wrapping cosmic chaos in a cautionary fable. Even the planets' names hide clues. Mars, named for the god of war, mirrors its rusty hue, a planet stained with iron oxide, the same element that colors blood. Venus, goddess of love, shines brightest at dawn and dusk, a beacon of beauty in the twilight. Mercury, the swift messenger, darts across the sky faster than any other planet, just as Hermes raced between worlds. These weren't random choices, they were observations crystallized into character. The Greeks didn't just see dots of light, they saw personalities, dramas, a cosmos alive with meaning. What makes these myths endure isn't just their poetry, but their precision. They were science in metaphor, a way to pass down knowledge before the language of equations existed. When we study them today, we're not just unraveling stories, we're decoding an ancient user manual for the universe written in the stars. Chinese astronomers of the Song dynasty peered into the night sky in the year 1054 and saw something impossible, a new star blazing beside the crescent moon, bright enough to outshine Venus and visible even in daylight. To them, it was a guest star, an unexpected visitor in the heavens that defied the celestial order. What they didn't know was that they were witnessing one of the universe's most violent events, a supernova explosion so powerful its remnants still glow today as the Crab Nebula. Their meticulous records, etched onto bamboo strips and silk scrolls, now serve as a time capsule for modern astrophysicists. The coordinates match perfectly with the crab's location, and the duration visible for 642 days aligns with contemporary models of stellar explosions. This wasn't just an observation, it was a collaboration across millennia, where ancient scribes unknowingly handed modern scientists a key to unraveling stellar life cycles. China's celestial record-keeping wasn't casual stargazing, it was a state-sponsored mission. Emperors ruled by the mandate of heaven, a divine right tied directly to cosmic harmony. Comets, eclipses, or guest stars weren't just astronomical events. They were omens, signals that the emperor's virtue might be waning. The Imperial Astronomical Bureau, staffed by scholar officials, operated like an early NASA, cataloging every anomaly with bureaucratic precision. They divided the sky into 28 lunar mansions, each tied to regions of Earth, creating a celestial map that doubled as a political tool. When a supernova flared, it wasn't merely studied, it was interpreted, debated, and woven into the empire's narrative. The Crab Nebula's appearance coincided with a period of reform under Emperor Renzong, who later commissioned star charts so accurate they included the guest star's precise position. What's striking is how these records blend myth and math. The Chinese saw the sky as a mirror of earthly governance, with stars as celestial officials. The North Star, unwavering, represented the emperor, while surrounding constellations symbolized his court. Supernovae were like rebellious ministers, unpredictable disruptions to the cosmic hierarchy. Yet beneath this symbolism lay rigorous science. Song Dynasty astronomers didn't just note the Crab supernova's brightness, they tracked its fading intensity over months, creating what modern researchers recognize as a light curve. Their bamboo strip archives even detail a broom star with a tail likely Halley's Comet in 1264, proving their distinction between different cosmic phenomena. The legacy of this system is staggering. While medieval Europe dismissed comets as portents of doom, Chinese astronomers were compiling data we still reference today. Their records of supernova in 185 CE and 396 CE helped identify remnants like RCW86 and G11.2-0.3. There's a profound lesson here. Science and storytelling once walked hand in hand. The same culture that saw heavenly omens in stellar explosions also laid the groundwork for empirical astronomy. Their dual lens, part divination, part deduction, reminds us that curiosity wears many faces. Whether mapping stars for an emperor or decoding the universe's expansion, humanity's quest remains the same: to find meaning in the infinite. Among the Pawnee people of the Great Plains, the rising of the morning star, what we call Venus, wasn't just a celestial event, it was a sacred call to renewal. Their morning star ritual, performed before the first light of dawn, reenacted the moment the star's divine power brought order to chaos. A young captive, often from an enemy tribe, would be dressed in symbolic regalia and sacrificed at the precise moment Venus appeared above the horizon. To modern ears, this sounds brutal, but the Pawnee saw it as a cosmic contract, a life given to ensure the sun's return, the crop's growth, and the tribe's survival. What's astonishing is the precision behind the ritual. Pawnee priests tracked Venus's complex cycles, knowing it appears as both morning and evening star in predictable patterns. Their ceremony wasn't superstition, it was astronomy encoded in tradition, a way to harmonize human life with the rhythms of the cosmos. Meanwhile, the Navajo people wove the night sky into their very identity. Their constellations weren't just pictures but maps, guides for planting, hunting, and storytelling. Take the star cluster we call the Pleiades. To the Navajo, it's Dilié, the seed stars. When these stars vanished in spring, it signaled the time to plant corn. When they reappeared in autumn, it warned of coming frost. The Big Dipper, that was Nahuko's Bika, the male revolving one, whose position helped track the seasons. But the Navajo didn't stop there. They noticed something most ancient cultures missed: the wobble of Earth's axis, called precession, which slowly shifts the stars' positions over centuries. Their stories speak of constellations walking across the sky, an observation modern science confirms takes 26,000 years to complete. Then there's the Hopi prophecy of the blue star Kachina, a celestial being said to herald the end of an age. When a brilliant blue-white star appeared in the sky, the Hopi warned it would bring upheaval before renewal. In 1997, astronomers witnessed something uncanny: the sudden brightening of a star in the constellation Cygnus, so intense it outshone the entire galaxy for weeks. Was this the blue star? The Hopi never claimed to predict exact dates, but their oral traditions preserved a truth science now acknowledges stars can explode, vanish, or flare in ways that reshape human understanding. These traditions weren't passive myths, they were living sciences. The Pawnee built earth lodges with smoke holes aligned to solstice sunrises, turning homes into observatories. The Zuni used petroglyphs to mark lunar standstills, the moon's most extreme northern and southern risings, events that only occur every 18.6 years. Even the Cherokee story of the Great Leech, a dark blotch in the Milky Way, corresponds to a real cosmic dust cloud modern astronomers call the Dark Horse Nebula. Indigenous sky wisdom didn't just observe the heavens, it integrated them into daily life, blending navigation, agriculture, and spirituality into a single, seamless knowledge system. What modern science often misses is the depth of ecological insight in these traditions. The Lakota didn't just track the stars, they noticed how certain constellations appeared when bison herds migrated or when medicinal plants reached peak potency. The Anishinaabe linked the phases of the moon not just to timekeeping but to the spawning cycles of fish. This wasn't astronomy in isolation. It was a holistic science where celestial patterns and earthly rhythms were threads in the same tapestry. When European settlers dismissed these practices as primitive, they overlooked the sophistication, oral traditions that preserved precise data for generations without written records, star maps etched not on paper but in memory and ritual. Today, as astronomers rediscover indigenous knowledge like the Aboriginal Australians' understanding of variable stars or the Incas' use of dark constellations in the Milky Way, we're forced to confront a humbling truth. The scientific method isn't the only path to cosmic understanding. For millennia, indigenous cultures maintained their own rigorous systems of observation, verification, and transmission. Their laboratories were the open plains, their data sets encoded in stories told around fires. The night sky wasn't a distant mystery to be solved but a familiar companion, its cycles as dependable as the seasons. In an age where light pollution obscures the stars for half the world, these traditions remind us that the cosmos isn't just above us, it's part of us, woven into the very fabric of how we live, grow, and remember. Long before laboratories and microscopes, alchemists peered into their crucibles and saw the cosmos reflected in molten metals and swirling vapors. To them, the seven classical metals gold, silver, iron, mercury, tin, copper, and lead weren't just elements but celestial ambassadors, each governed by a planet's influence. Gold bore the sun's radiant purity, silver the moon's cool glow, while iron resonated with Mars's warlike energy. These weren't arbitrary connections. Alchemists observed how metals behaved, how mercury flowed like quicksilver, echoing Mercury the planet's swift orbit, or how copper's reddish hue mirrored Venus's rosy dawn appearance. Their symbols, cryptic glyphs etched into manuscripts, were more than shorthand. They were a language linking earth and sky, matter and mystery. Fast forward to the 19th century, when chemists like John Dalton began organizing elements into the first periodic tables. Look closely at Dalton's original notations, and you'll spot something remarkable. His symbol for gold was a circled dot, the alchemical sign for the sun. Silver, a crescent moon, just as the ancients drew it. Even iron's symbol, an arrow pointing upward, echoed Mars's shield and spear glyph. This wasn't nostalgia, it was practicality. Alchemy's visual lexicon had permeated science so deeply that early chemists simply adapted what worked. Over time, these symbols evolved into the letters we know today. O for gold from aurum, Ag for silver, argentum, but the cosmic thread remained. The sun and gold still share a circle in astronomy's shorthand, a silent nod to their ancient kinship. Yet the parallels run deeper than symbols. Alchemists sought the philosopher's stone, a legendary substance said to transmute base metals into gold and grant eternal life. To modern ears, it sounds like fantasy until you consider particle physics. Today's scientists collide atoms in massive accelerators, attempting to create rare, unstable elements or even islands of stability where matter might behave in unprecedented ways. The goals aren't so different. Both pursuits aim to unlock matter's hidden potentials, to bend the rules of nature through experimentation. When alchemists wrote of solve et coagula, dissolve and recombine, they anticipated chemistry's foundational principle, breaking and reforming molecular bonds. The most striking overlap lies in their shared obsession with mercury. Alchemists revered it as the prima materia, the primal substance underlying all creation, capable of dissolving metals without destroying them. Modern science reveals why. Mercury's unique electron configuration allows it to form amalgams with other metals, a property exploited in gold extraction and dental fillings. Even the alchemical Ouroboros, the snake eating its tail, finds resonance in nuclear physics, where decay chains cycle elements through transformations until reaching stable state. Perhaps the greatest lesson alchemy offers isn't about elements but epistemology, how we know what we know. Alchemists worked without the scientific method, yet their meticulous experiments laid groundwork for metallurgy, medicine, and materials science. When Isaac Newton, often hailed as the father of physics, scribbled over 1 million words on alchemy, he wasn't dabbling in nonsense. He was grappling with the same questions that drive researchers today. What is matter made of? How do forces interact, and what hidden patterns govern the visible world? The answers have changed, but the wonder remains. Every time a chemist uses a symbol or a physicist smashes particles, they walk a path first traced by those who sought the secrets of the stars in the crucible's glow. While Europe's libraries crumbled under the weight of the so-called Dark Ages, a revolution was unfolding under the domes of Baghdad's House of Wisdom. Here in the 9th century, scholars like Al-Khwarizmi weren't just preserving ancient Greek texts, they were rewriting the rules of the cosmos. Take Al-Biruni, a polymath who calculated Earth's circumference with a margin of error under 2%, using little more than a brass astrolabe and trigonometry. His method was ingenious. He measured the angle of a mountain's peak from 2 different locations, then applied geometric principles to deduce the planet's curvature. This wasn't guesswork, it was rigorous science, conducted 600 years before Europeans accepted Earth wasn't flat. Then there's Ibn al-Haytham, known in the West as Al-Hazan, who shattered a belief that had endured since Aristotle. That light emanated from the human eye to illuminate objects. Through painstaking experiments with camera obscuras and lenses, he proved vision works the opposite way light reflects off objects into our eyes. His Book of Optics didn't just debunk celestial spheres, it laid the foundation for everything from telescopes to modern ophthalmology. But perhaps his most radical idea was the concept of controlled experimentation, insisting theories must be tested rather than relying on tradition. This principle would later echo in the halls of the Royal Society, shaping the very core of the scientific method. The tools they invented were as groundbreaking as their theories. The astrolabe, refined by Islamic astronomers, became the medieval equivalent of a smartphone, a handheld device that could predict star positions, calculate prayer times, and even survey land. Zij star catalogues, like Ulugh Beg's 15th century masterpiece, mapped over 1,000 stars with unprecedented precision, correcting Ptolemy's errors. And let's not forget algebra, a gift from Al-Khwarizmi's seminal work, which gave astronomers the language to describe planetary motion mathematically. These weren't isolated advances. They formed an interconnected web of progress where mathematics fed astronomy, which in turn refined navigation and timekeeping. What's often overlooked is how Islamic astronomy bridged cultures. When the Abbasid Caliph Al-Ma'mun ordered Greek texts translated into Arabic, he didn't just preserve them, he unleashed a cross-pollination of ideas. Hindu numerals from India merged with Babylonian trigonometry and Persian observational techniques, creating a new global science. The Maragha Observatory in 13th century Persia, with its towering mural quadrants and mechanical calendars, became a melting pot where Jewish, Christian, and Muslim scholars collaborated freely. Their shared goal, to crack the code of the heavens regardless of whose god ruled there. The legacy of this golden age radiates through history. Copernicus's heliocentric model, which ignited the scientific revolution, borrowed heavily from Nasir al-Din al-Tusi's Tusi couple, a mathematical model explaining how circular motions could produce straight-line movement. Even Kepler's laws of planetary motion owe a debt to Ibn al-Shatir's 14th century diagrams, which replaced Ptolemy's clumsy epicycles with elegant, intersecting orbits. These weren't coincidences, they were transmissions of knowledge passed like a torch from Damascus to Cordoba, then across the Pyrenees to medieval Europe. Why does this matter today? Because it rewrites the narrative of scientific progress. The story isn't one of Greece passing wisdom directly to Renaissance Europe. It's a tapestry woven across continents and faiths, where progress flowed along trade routes and through translation houses. When we gaze at the stars through modern telescopes, we're seeing with lenses first polished by minds who prayed toward Mecca, wrote in Arabic, and saw the universe as a puzzle waiting to be solved with numbers and reason. Their light still reaches us centuries later. Tycho Brahe's observatory at Uraniborg wasn't just a workplace, it was a cathedral to precision, built on an island gifted by a king who believed the stars held secrets of statecraft. With no telescopes yet invented, Brahe relied on giant brass quadrants and mural arcs, instruments so precise they could measure planetary positions down to 1 arcminute, about the width of a fingernail at arm's length. His meticulous logs of Mars's retrograde motion would later give Kepler the data to crack planetary orbits, but here's the twist: Brahe's patrons weren't funding pure science. Danish nobles and Holy Roman emperors wanted horoscopes, believing celestial alignments could predict wars, plagues, or royal fortunes. Every observation of a comet or eclipse came with an astrological report attached, blending cutting-edge astronomy with medieval mysticism. Then there's Galileo, whose sketches of Jupiter's moons in 1610 shattered the idea that all heavenly bodies orbited Earth. But flip through his notebooks and you'll find more than diagrams. There are frantic calculations trying to link the moon's movements to musical intervals, chasing Pythagoras' ancient dream of the harmony of the spheres. Even as his telescope revealed craters on the moon and spots on the sun, Galileo couldn't fully escape the mystical frameworks of his time. He famously named Jupiter's satellites the Medicean stars after his patron Cosimo de Medici, not just to flatter but because Renaissance science thrived on such symbiosis. Without noble patronage, there'd be no lenses polished, no observatories built, but with it came expectations to serve power as much as truth. Kepler's struggle epitomizes this tension. His 3 laws of planetary motion, deduced from Brahe's data, became pillars of modern astrophysics. Yet his masterwork, Harmonices Mundi, spends pages not on equations but on linking planetary orbits to platonic solids and musical notes. To Kepler, the solar system wasn't just a mechanical clockwork but a divine composition, with each planet's speed corresponding to a tone in a cosmic choir. When he calculated Mercury's song as a high G, it wasn't metaphor. He believed celestial harmonies literally resonated through space, a philosophy that would get dismissed as mysticism today. But strip away the poetry, and you find astonishing rigor. Kepler's musical ratios align with the inverse square relationship later formalized by Newton, proving that intuition sometimes dances ahead of proof. The Renaissance astronomers' true genius lay in their duality. They stood with one foot in the medieval world, where comets were omens and planets bore gods' names, and the other in a dawning age of empiricism. Brass' prosthetic nose replacing one lost in a duel symbolizes this bridge, a blend of archaic violence and cutting-edge metallurgy. Their legacy reminds us that science doesn't advance in straight lines but through messy, human contradictions. The same man who charted Jupiter's moons might also cast horoscopes. The mathematician who unlocked elliptical orbits still searched for God's hand in geometry. What separates them from their predecessors wasn't just better tools but a willingness to let observation override tradition. When Galileo saw Venus waxing and waning like a tiny moon, he knew Ptolemy's Earth-centered model was doomed, even if saying so risked heresy. Bra's supernova observations proved the heavens could change, contradicting Aristotle's perfect, immutable spheres. Kepler, for all his mysticism, scrapped his beloved circular orbits when the numbers demanded ellipses. Their breakthroughs came not by rejecting the past but by holding it loosely, letting the stars themselves dictate which ancient ideas to keep and which to discard. The lesson for us: every scientific revolution begins with heretics who dare to see differently. The Renaissance astronomers didn't have all the answers, but they asked the right questions, not just what do the stars do. But how can we truly know? Their answer through painstaking measurement, public debate, and the humility to revise became the bedrock of modern science. The fact that they did so while navigating astrological whims and patron politics makes their achievements all the more extraordinary. They taught us that the universe speaks in numbers, but it takes human curiosity to listen. Isaac Newton's apple might be science's most famous fruit, but the story behind it reveals something deeper, a mind torn between rigid mathematics and mystical wonder. When he formulated the law of universal gravitation in 1687, he didn't just give us equations. He gave the cosmos a kind of order no one had imagined before. Planets no longer needed angels to push them in their orbits, as medieval scholars had speculated. Instead, they moved with clockwork precision, governed by an invisible force acting across empty space. To the scientists of his day, this was revolutionary, but to ancient cultures who saw the heavens as alive with spirits and intention, Newton's gravity might have felt less like a breakthrough and more like a translation, an algebra of forces replacing the poetry of divine will. Consider how earlier civilizations explained celestial motion. The Maya envisioned the Milky Way as a cosmic serpent, its undulations shaping time itself. Hindu texts described planets as chariots pulled by celestial horses, their speed varying with the gods' whims. Even the Greeks, with their geometric models, saw planetary retrograde motion as the gods pausing to dance among the stars. These weren't naive fantasies, they were sophisticated attempts to reconcile observation with intuition. When Newton reduced these motions to F equals G times m1 m2 over r squared, he didn't just solve a puzzle. He severed the ancient link between physics and philosophy. The universe in his hands became a machine predictable, measurable, but perhaps less wondrous. yet Newton himself would have bristled at this interpretation. The same man who quantified gravity spent decades deciphering biblical prophecies and practicing alchemy in secret. His notebooks contain over 1 million words on topics like the Philosopher's Stone and the sacred geometry of Solomon's Temple. To Newton, these weren't contradictions but complementary pursuits, different lenses to view the same divine blueprint. He believed gravity's equations revealed God's handiwork, a hidden order beneath the chaos. In this light, his science wasn't so far from the Babylonian astrologers who saw Jupiter's movements as messages from Marduk. Both sought patterns in the sky. Newton simply preferred his patterns mathematical. The tension between these worldviews still echoes today. Modern physics tells us gravity isn't even a force in the traditional sense. It's the curvature of space-time, a concept as alien to Newton as his calculus would have been to Ptolemy. But just as Newton bridged myth and math, Einstein's relativity later bridged Newton's mechanics with a stranger, more flexible cosmos. The through line here isn't the death of mystery, but its evolution. Ancient sky watchers personified the planets. Newton depersonified them but kept the awe. Einstein made spacetime itself the protagonist. Each step didn't erase the past but reframed it, like translating a poem into another language. The words change, but the music lingers. Perhaps the real lesson lies in Newton's unpublished alchemical manuscripts, where he describes the universe as a sensorium of the divine. For all his equations, he never lost the sense that the cosmos was more than gears and pulleys. Maybe the ancients would have understood that better than his Enlightenment peers. When a Navajo elder today speaks of the holy wind that binds all things, or a Taoist describes the interplay of yin and yang as cosmic gravity, they're articulating what Newton's numbers hinted at, that the force tying apple to earth and earth to sun is more than a formula. It's the whisper of something older than science, a truth that equations can describe but never fully contain. Einstein's theory of relativity didn't just rewrite physics, it quietly echoed whispers from humanity's oldest myths. Take time dilation, that mind-bending effect where clocks tick slower near massive objects or at high speeds. To a Hindu sage, this wouldn't sound revolutionary at all. Their scriptures describe time as layered, like concentric ripples in a pond where one cosmic age, or yuga, flows differently than another. The Mahabharata even speaks of King Kakadmi traveling to the realm of Brahma for what felt like moments, only to return and find Earth had aged centuries. Sound familiar? It's the same principle as Einstein's twin paradox, where an astronaut speeding through space comes home younger than their sibling. The language differs, equations versus epics, but the intuition is startlingly similar. Time isn't absolute. It breathes, bends, and dances to rules beyond human perception. Now picture spacetime as a fabric, warped by stars and galaxies like weights on a stretched sheet. This image, central to general relativity, finds uncanny parallels in ancient cosmologies. The Norse envisioned Yggdrasil, an immense world tree whose roots and branches connected 9 realms. Some say this wasn't just metaphor but an early grasp of cosmic interconnectedness. Aboriginal Australians describe the dream time as a dimension where past, present, and future exist simultaneously, much like relativity's block universe theory, where time is a fixed landscape we move through. Even the Mayan concept of Kain, meaning both sun and time, hints at an understanding that celestial bodies don't just mark time, they shape its very flow. What's most striking isn't just these similarities but their implications. Einstein showed that space and time aren't separate. They're threads in a single cosmic tapestry, just as the Hopi language lacks distinct words for space and time, treating them as one concept, Tunatia. Modern physicists speak of quantum entanglement, where particles instantaneously influence each other across vast distances, a notion that would have felt natural to a Buddhist monk describing Indra's net, a jeweled web where every gem reflects all others infinitely. These aren't mere coincidences, they're different dialects describing the same profound truth. The universe is far more fluid and interconnected than our senses suggest. Perhaps the deepest resonance lies in the idea of perspective. Relativity teaches that observations depend on the observer's frame of reference, an insight mirrored in the Hindu parable of 6 blind men and an elephant, each perceiving the animal differently based on what part they touch. The Aztecs took this further with their Nepantla philosophy, embracing the tension between contradictory viewpoints as the truest path to understanding. Einstein would have agreed, his universe has no privileged vantage point, no center, just as the ancient Greeks' omphalos, or world navel, wasn't a physical place but a symbolic reminder that every perspective is equally valid. Does this mean ancient cultures somehow grasped relativity? Not in the mathematical sense, but their myths and metaphors encoded intuitive wisdom about a flexible, relational cosmos wisdom that science is now verifying with precision instruments. The Taoist yin-yang symbol, with its swirling interdependence, could almost be a diagram of space-time curvature. The Dogon's description of the universe as a spiral of spirals anticipates our modern view of galaxies spinning in an expanding continuum. Even the biblical phrase, 1,000 years is as one day, takes on new meaning when you consider time's elasticity near a black hole. This convergence raises a tantalizing question. Did these traditions preserve fragments of lost knowledge, or is the human mind wired to perceive certain cosmic truths, whether through myth or math? Either way, Einstein's universe and ancient cosmologies share a common thread: the recognition that reality is far stranger, far more wondrous than it appears. When physicists today speak of wormholes or multiverses, they're continuing humanity's oldest conversation, one that began when the first storyteller looked up at the stars and dared to imagine how it all connects. Erwin Schrödinger's famous thought experiment, a cat simultaneously alive and dead in a sealed box, was meant to expose the absurdity of quantum superposition. Yet in Hindu philosophy, this paradox wouldn't seem strange at all. The concept of Maya, the illusion that veils true reality, teaches that all perceived opposites, life and death, existence and emptiness, are ultimately inseparable. Just as Schrödinger's cat exists in a blurred state until observed, ancient texts like the Upanishads describe the universe as a divine play of appearances, where nothing is fixed until consciousness interacts with it. The parallels run deeper than metaphor. Quantum physics tells us particles don't have definite properties until measured, existing instead as probability waves. Advaita Vedanta, a school of Hindu thought, insists the tangible world is similarly fluid, a shimmering projection of Brahman, the ultimate reality, much like how quantum fields underlie everything we perceive. Now consider entanglement, that eerie phenomenon where two particles remain mysteriously linked across vast distances, instantly mirroring each other's states. Taoist philosophy described this unity millennia ago in the yin-yang symbol, two halves eternally bound, each containing the seed of the other. The Chinese sage Zhuangzi captured entanglement's essence when he wrote of waking from a dream, unsure whether he was a man dreaming of a butterfly or a butterfly dreaming of a man. This isn't poetic whimsy, it's a profound recognition that separation might be an illusion. Modern experiments confirm entangled particles behave as a single system regardless of space, echoing Taoism's view that all things arise from the same primordial Kai, or life force. Even the quantum vacuum, seething with virtual particles blinking in and out of existence, mirrors the Taoist Wu Jai, the boundless void from which all forms emerge and return. Buddhism's teachings on emptiness resonate just as powerfully. The Heart Sutra declares, "Form is emptiness, emptiness is form," a statement that could double as a quantum physicist's musing on wave-particle duality. At the subatomic level, particles appear and vanish like ephemeral notes in a cosmic symphony, their existence dependent on interaction, not unlike Buddhist teachings that all phenomena lack inherent, independent reality. The Tibetan concept of tendril, meaning interdependent origination, mirrors quantum field theory's web of relations where particles derive meaning only through connection. When physicists say an electron exists everywhere and nowhere until measured, they're echoing Nagarjuna's 2nd century assertion that nothing exists intrinsically, only relationally. These parallels aren't mere coincidence. They reflect humanity's enduring intuition about reality's flexible nature. Indigenous Australian shamans speak of dreamtime, where past, present, and future coexist, a concept resembling the quantum many worlds interpretation where all possibilities unfold simultaneously. The Kabbalistic tree of life, with its 10 interconnected spheres, mirrors the multidimensional string theory landscape. Even the Christian mystic Meister Eckhart's declaration that the eye with which I see God is the same eye with which God sees me finds resonance in quantum observer effects, where measurement shapes the measured. What unites these traditions isn't prescient knowledge of subatomic physics, but a shared willingness to question appearances. Quantum mechanics didn't invent radical interconnectedness, it quantified what mystics have articulated for ages. The difference lies in method. Where physicists use particle colliders and mathematics, contemplatives turned inward, probing consciousness itself as the ultimate laboratory. Both paths, in their own ways, dissolve the illusion of separateness, revealing a universe far more mysterious and alive than our senses suggest. Whether through meditation or mathematics, the message remains reality is a dance of potentialities, and we, the observers, are partners in its unfolding. Modern telescopes can map the spin of galaxies, the bend of light around clusters, even the faint afterglow of the Big Bang, yet they're blind to the very thing holding it all together. Dark matter, that mysterious substance making up 85% of the universe's mass, leaves no trace except its gravitational fingerprint. It's as if the cosmos is haunted by its own scaffolding, an invisible architecture first suspected when galaxies whirled faster than their visible stars should allow. But here's the twist. This isn't the first time humanity has grappled with unseen forces shaping reality. The Sumerians spoke of the Anunnaki, gods who moved through the world like wind, their presence known only by the order they imposed. The Egyptians envisioned the Duat, a shadowy underworld where the sun god Ra traveled by night, its geography mirrored in the stars above. These weren't just myths, they were attempts to explain the inexplicable, to give form to forces that shaped their world without revealing themselves. Take the Babylonian creation epic Enuma Elish, where the god Marduk slays the chaos dragon Tiamat and fashions the heavens from her corpse. The story reads like allegorical astrophysics. Tiamat's invisible essence, scattered through the cosmos, becomes the unseen hand that guides celestial motion. Or consider the Hindu concept of Akasha, an imperceptible fifth element permeating space, not unlike the dark matter halos modern simulations show enveloping galaxies. Even the Norse prose Edda describes Yggdrasil, the world tree, as rooted in hidden realms where more things are than men can know. These cultures weren't describing dark matter as we understand it, but they captured something profound, the intuition that what we see is only a fraction of what exists. The parallels grow eerier when you examine how dark matter behaves. It doesn't collide, emit light, or interact with ordinary matter except through gravity qualities that recall descriptions of spirits or ancestral beings in countless traditions. The Aboriginal Australians' Dreamtime ancestors shaped landscapes invisibly, leaving only their handiwork as evidence, much like dark matter sculpts the cosmic web. The Taoist wu-wei, or effortless action, mirrors dark matter's paradox. It's everywhere yet does nothing we can directly detect. Even medieval alchemists' ether, an intangible medium thought to fill the void between stars, feels like a prescient metaphor for the dark matter filaments stretching across intergalactic space. What's fascinating is how both ancient myths and modern physics confront the same dilemma, explaining influence without visible cause. When astrophysicists map dark matter by watching how it bends light, a technique called gravitational lensing, they're not so different from Mayan priests reading the future in the distorted reflections of sacred cenotes. Both are interpreting shadows cast by the unseen. The difference is our tools. Where elders once relied on intuition and oral tradition, scientists now use billion-dollar detectors buried deep underground, hunting for hypothetical particles like WIMP or actions. Yet both traditions share a humbling truth: we're like goldfish in a pond, unaware of the hands that pour the water. This convergence raises a provocative question. Could myths preserve ancestral observations of cosmic phenomena we're only now quantifying? The Dogon people's knowledge of Sirius B, a star invisible to the naked eye, suggests some traditions encoded precise astronomy long before telescopes. Might other cultures have sensed dark matter's presence through its gravitational whispers, interpreting it as divine will or ancestral force? We'll never know for certain, but the resemblance between ancient cosmologies and cutting-edge astrophysics invites us to reconsider what knowing really means. Sometimes the oldest stories hold the newest truths not in their details, but in their recognition that the universe is far stranger, far more hidden than it appears. Black holes defy everything we know about physics, places where gravity grows so intense that not even light can escape their pull. Yet across cultures, these cosmic devourers find eerie reflections in ancient symbols of cyclical destruction and rebirth. The Ouroboros, that ancient serpent forever consuming its own tail, captures the paradox at a black hole's heart, an end that feeds a beginning. In Norse mythology, the great wolf Fenrir's gaping maw swallows the sun during Ragnarök, only for a new world to emerge from the void. The Maya saw the Milky Way as a dark road, a celestial serpent whose winding path mirrored the inescapable grip of an event horizon. These aren't just poetic parallels, they're humanity's earliest attempts to describe the indescribable, to give form to cosmic forces that annihilate and regenerate in the same breath. Consider the Hindu goddess Kali, her necklace of skulls symbolizing time's relentless consumption of all things. Her tongue lolls out not just in fury but in insatiable hunger, a vivid echo of the accretion disks swirling around black holes where matter is stretched and shredded into luminous plasma before vanishing forever. Or take the Aztec Zucotl, the fire serpent that both destroys and renews the world in 5,000-year cycles, much like how black holes eventually evaporate via Hawking radiation, returning energy to the cosmos in their dying moments. Even the Aboriginal rainbow serpent, which shapes landscapes by swallowing and regurgitating ancestral beings, mirrors the way black holes might birth new universes through their singularities, as some theoretical physicists proposed. What's striking is how these myths anticipated modern astrophysics' wildest ideas. The Maya's dark road aligns uncannily with the concept of a wormhole, a tunnel through space-time potentially lurking at a black hole's core. Their Dresden Codex even describes a cosmic mouth that inhales stars reminiscent of Sagittarius A, the supermassive black hole at our galaxy's center. The ancient Egyptians' Apep, the serpent of chaos who battles the sun god Ra each night, embodies the violent turbulence of matter crossing an event horizon. And when the Gnostic texts speak of a dragon whose tail is in its mouth, encircling the universe, they might as well be describing the photon sphere, the point near a black hole where light orbits endlessly, trapped in a loop of its own making. The deeper connection lies in the symbolism of thresholds. Black holes represent the ultimate boundary, the point where known physics collapses and time itself distorts. Similarly, mythic serpents often guard portals between worlds. The Norse Jörmungandr, coiled around Midgard, marks the edge of the known universe. The Chinese dragon Zhulong, whose eyelids opening and closing create day and night, governs transitions between states of being. Even the Greek Hydra, whose heads regrew when severed, reflects the holographic principle, the theory that all information swallowed by a black hole might be encoded on its surface, preserved even as the interior is obliterated. Perhaps these recurring motifs reveal something fundamental about how humans process cosmic terror. Faced with phenomena that defy comprehension, whether a star's collapse or the universe's cyclical death, we reach for the same archetypes: serpents, maws, vortices. They're visceral metaphors for forces too vast to name. When modern astronomers describe black holes as time machines or cosmic recyclers, they're continuing this tradition, translating equations into narratives the human mind can grasp. The Ouroboros still spins, after all, not just in alchemical texts but in simulations of spinning black holes, where space-time itself twists into a self-devouring loop. The ancients may not have known general relativity, but their stories encoded a truth science now confirms. Destruction and creation are two sides of the same coin, endlessly flipping in the dark. Long before telescopes revealed planets orbiting distant suns, humanity's myths were already populated by beings from beyond the stars. The Dogon people of Mali spoke of the Namo, amphibious entities who descended from Sirius in a vessel that roared like thunder, bringing knowledge of astronomy and agriculture. Ancient Sumerian tablets describe the Anunnaki, gods who came from the heavens to mine Earth's resources, their home planet Nibiru orbiting beyond Neptune. Even the biblical Nephilim, giant offspring of sons of God and human women, echo this recurring theme. Visitors from the cosmos, whether divine or monstrous, threading their way through our oldest stories. Today, as astronomers catalog over 5,000 confirmed exoplanets, these tales take on new resonance. Were they merely imaginative fictions, or could they encode ancestral encounters, or at least intuitions about life beyond our world? Consider the sheer specificity of some accounts. The Dogon's knowledge of Sirius B, a white dwarf star invisible to the naked eye, has baffled researchers for decades. Their legends describe it as small, dense, and crucially orbiting Sirius every 50 years, a detail modern astronomy confirms. How did a culture without optical instruments grasp such precise celestial mechanics? Skeptics suggest contamination from early European visitors, yet Dogon oral traditions predate Western contact by centuries. Similarly, the Hopi speak of the blue star Kachina, a celestial harbinger whose appearance would precede great upheaval. In 1997, astronomers observed a previously unknown blue star, V433 Cygni, flare to unprecedented brightness, a coincidence that still sparks debate. Then there's the curious case of Nibiru, the Sumerian planet of the crossing. While no such world exists in our solar system, exoplanet hunters have since discovered rogue planets, nomadic worlds drifting between stars, untethered to any sun. Could the Anunnaki myth reflect an ancient awareness of these cosmic wanderers? Even the Norse Yggdrasil, with its 9 interconnected realms, finds an eerie parallel in the TRAPPIST-1 system, where 7 Earth-sized planets orbit a red dwarf in delicate gravitational harmony. These parallels don't prove ancient extraterrestrial contact, but they reveal something profound. Humanity's myths often anticipated the cosmic diversity science is now confirming. The psychological angle is just as compelling. Carl Jung coined the term collective unconscious for archetypes that recur across cultures like the celestial visitor. From the Greek gods descending Olympus to the Aboriginal sky heroes who shaped the land, this motif persists globally. It's as if the human mind, gazing at the stars, instinctively sensed we weren't alone. Modern SETI scientists argue this intuition aligns with the Drake equation's optimistic odds of galactic civilizations. But there's another possibility. These stories encode terrestrial truths. The Nomo's aquatic nature might reflect ancestral memories of early hominids coexisting with amphibious mammals, while the Nephilim's gigantism could symbolize encounters with now extinct megafauna. Myths, after all, are palimpsests layered with meaning, both celestial and earthly. What makes this dialogue between myth and science so vital is its humility. The more exoplanets we discover, water worlds shrouded in steam, diamond planets glittering with crystallized carbon, super-Earths with crushing gravity, the more we realize how narrow our imagination has been. Ancient stories, unfettered by rigid astrophysics, envisioned realms far wilder than we dared, flying cities, crystal skies, beings of pure light. Perhaps they weren't documenting visits but dreaming possibilities, their myths less about the past than about futures we're only now beginning to map. As the James Webb Telescope peers into the atmospheres of distant worlds, we might do well to revisit these old tales not as literal truths, but as cosmic roadmaps, reminding us that the universe has always been stranger than we suppose. And if we ever do encounter life beyond Earth, we'll find ourselves part of a conversation that began when the first storyteller looked up and wondered who else might be looking back. The modern search for extraterrestrial intelligence scans the cosmos with arrays of radio telescopes, listening for faint whispers amid the static of stars. Yet thousands of years before Frank Drake penned his famous equation, our ancestors were already documenting encounters with beings from beyond Earth. In the caves of Val Camonica, Italy, prehistoric artists carved figures with elongated heads and radiating halos, floating above crowds of awestruck humans. The Sanskrit Vedas describe the Vimanas flying chariots piloted by celestial beings who shared knowledge of astronomy and medicine. Even the biblical prophet Ezekiel's vision of wheels within wheels descending from the sky reads like a first-hand account of advanced machinery to modern eyes. These aren't isolated fantasies, they're recurring narratives across cultures separated by oceans and millennia, all pointing skyward with the same question: are we alone or have we already been found? What if these ancient accounts aren't just myths but distorted memories of contact? The Dogon tribe's precise knowledge of Sirius B's 50-year orbit, or the Sumerian tablets detailing planetary positions impossible to see without telescopes, challenge easy dismissal. Some researchers propose these details were imparted by advanced visitors, a theory called paleocontact. While mainstream science remains skeptical, the parallels are unsettling. The Aboriginal Australian Wandjina spirits, painted with large eyes and no mouths, resemble modern depictions of grey aliens. The Tibetan Buddhist texts speak of Shambhala, a hidden kingdom where enlightened beings preserve cosmic knowledge in flying pearl vessels. Even the medieval Nuremberg Chronicle describes a 1561 celestial battle involving spheres and crosses, an event some interpret as a UFO sighting recorded by an entire city. Yet SETI scientists approach these stories with cautious curiosity. The WOW signal, a 72-second burst of radio waves detected in 1977, remains the closest we've come to potential extraterrestrial communication. But ancient texts suggest other modes of contact. The Hindu Mahabharata describes divine weapons that could only be activated by chanting specific sound frequencies, hinting at technology harnessing vibrational energy. The Aboriginal songlines, oral maps of the land encoded in melodies, demonstrate how information might be transmitted through non-linear means. Could interstellar messages be hidden not in radio waves but in quantum entanglement or neutrino pulses, methods we're only beginning to explore? The ethical dimension looms large. Native American traditions warn of the Star People's gifts bringing both wisdom and imbalance. The Hopi speak of previous worlds destroyed when humanity misused advanced knowledge. These cautionary tales resonate with modern concerns about active SETI, broadcasting our location into the cosmos. Astrophysicists like Stephen Hawking warned against announcing ourselves to potentially predatory civilizations, while others argue secrecy is futile for a species already leaking radio waves for a century. Ancient stories offer a third perspective. Contact might not be a singular event but a gradual reveal tailored to our readiness. The Vedic concept of yugas, cyclic ages of awakening, suggests extraterrestrial interaction could unfold across epochs, not decades. Perhaps the most profound lesson from these accounts is the universality of the search. Whether through Pueblo Kiva ceremonies invoking star ancestors or the Allen telescope array passing cosmic noise, humanity's gaze remains fixed on the same infinite horizon. The methods have changed, from shamans interpreting visions to algorithms analyzing spectral lines, but the longing persists. In the end, ancient contact stories may not prove extraterrestrial visitation, but they undeniably prove something equally significant. We've always known the cosmos is alive with possibility. Whether SETI first confirmed signal arrives tomorrow or in 1,000 years, it won't be the beginning of our conversation with the stars, only the latest chapter in a dialogue as old as consciousness itself. From the icy peaks of the Andes to the floodplains of Mesopotamia, nearly every ancient culture tells the same terrifying story, a great deluge that once wiped the earth clean. The Bible's Noah builds an ark to survive divine judgment, while Hindu texts describe Manu, the first man, saved by a fish who warns of coming waters. The Sumerian epic of Gilgamesh speaks of Utnapishtim, instructed by gods to construct a massive vessel before the storm. These aren't isolated tales but a global chorus of memory passed down through generations. What if these stories aren't just allegories but encrypted warnings? Modern geology reveals that around 7,000 years ago, melting glaciers triggered catastrophic flooding as the Black Sea transformed from a freshwater lake to a saltwater basin, swallowing entire coastlines. Similar events occurred in the Persian Gulf and the Sunda Shelf, where rising seas submerged land bridges the size of continents. The parallels are too stark to ignore. Our ancestors may have been documenting real climate disasters, encoding survival lessons in myth. Look closer at the details. The Babylonian flood myth describes torrents so violent they tore the mooring posts from the earth, language that mirrors geological evidence of ancient mega-tsunamis. Aboriginal Australian stories tell of ancestral beings like the rainbow serpent reshaping the land as seas rose after the last ice age, coinciding with scientific timelines of glacial retreat. Even Plato's account of Atlantis, a civilization swallowed by the ocean, aligns with the Mediterranean's sudden inundation 5.3 million years ago when the Strait of Gibraltar burst open. These narratives share uncanny consistencies: divine warnings ignored, last-minute escapes on boats or rafts, and the preservation of seeds or animals echoing modern disaster preparedness protocols. The Haida people of the Pacific Northwest recount how Raven guided survivors to mountaintops as waters rose, a story that matches geological records of rapid sea level increases along the coast. Yet the most chilling connection lies in the cyclical nature of these tales. Hindu cosmology speaks of recurring floods at the end of each cosmic age, or yuga, a concept that resonates with today's understanding of Ice Age cycles. The Mayan Popol Vuh describes earlier versions of humanity destroyed by water, fire, and storms, each collapse followed by rebirth. Modern climate models now warn of similar patterns: feedback loops where melting permafrost releases methane, accelerating warming in a self-perpetuating spiral. The ancient Greek story of Deucalion's flood even includes a detail modern scientists recognize: a bronze sky that could describe the eerie light refraction caused by volcanic ash or intense atmospheric changes. What sets these myths apart from mere disaster accounts is their prescriptive wisdom. The Kogi people of Colombia, who call themselves Elder Brothers, have long warned of ecological imbalance, citing prophecies passed down since pre-Columbian times. Their Great Mother's Law dictates that taking too much from nature invites catastrophe, a principle now quantified in climate science as tipping points and carrying capacity. Norse Ragnarok isn't just about gods battling monsters. It's a blueprint for resilience where two humans hide in Yggdrasil's roots to repopulate the world. These stories don't just predict doom, they offer templates for adaptation, much like today's calls for sustainable architecture or seed banks. The lesson here isn't that ancient people predicted anthropogenic climate change, but that they understood something fundamental about Earth's rhythms. Their myths encoded hard-won knowledge: coastlines shift, weather patterns oscillate, and survival depends on heeding subtle warnings. As satellite data confirms Antarctic ice sheets crumbling at unprecedented rates, these old narratives take on new urgency. The same seas that swallowed Doggerland and Sundal and now threaten Miami and Mumbai. Perhaps the true message of these flood stories isn't about wrathful gods, but about human fallibility, our tendency to build in floodplains, ignore environmental signals, and repeat the same mistakes across millennia. The Ark, the fish, the mountaintop refuge, they're not just plot devices but survival strategies etched into collective memory, waiting for us to listen. NASA Perseverance rover drills into Martian bedrock, searching for microscopic fossils in rust-colored dust, a scene that would feel eerily familiar to the Sumerians, who 4,000 years ago wrote of gods needing life from clay. Modern astrobiology and ancient creation myths share a surprising obsession: the idea that life emerges from inert matter, whether through biochemical processes or divine breath. The Aboriginal Australians speak of the Wandjina, ancestral beings who shaped landscapes and imbued them with life force. The Norse believed the first humans, Ask and Embla, were carved from driftwood by Odin and given consciousness. Even the biblical Genesis describes Yahweh molding Adam from the dust of the ground, an image that takes on new resonance when we consider how Earth's earliest microbes likely formed in mineral-rich tidal pools. These parallels aren't coincidental. They're humanity's collective intuition about life's deepest mystery. How does non-living matter become alive? The chemistry behind this transition fascinates researchers today. In labs, scientists simulate primordial Earth conditions, mixing water, ammonia, and methane under ultraviolet light to produce amino acids, the building blocks of proteins. These experiments echo the Maori creation story of Tain Mahuta, who pressed his forehead against the sky father Ranganui to separate heaven and earth, releasing the essential elements for life. The Hindu Rigveda takes it further, describing cosmic waters called Apa as the womb of creation, where heat and desire transformed chaos into order, a poetic mirror of hydrothermal vent theories, where superheated mineral plumes may have catalyzed early cell formation. Whether through lightning striking a primordial soup or gods breathing into clay, the underlying narrative remains. Life arises where energy meets matter in precise alchemy. Mars adds another layer to this convergence. When NASA Viking landers conducted their famous labeled release experiments in 1976, the ambiguous results sparked debates that still linger. Did the soil samples metabolize nutrients, hinting at microbial activity, or was it just exotic chemistry? This uncertainty mirrors the Zulu myth of Unkulunkulu, who broke off from reeds in a primordial swamp, neither fully divine nor fully mortal, but something in between. The Perseverance rover's current mission, caching samples for eventual return to Earth, feels like a scientific retelling of the Egyptian Osiris myth, where dismembered fragments must be reassembled to restore life. Both endeavors grapple with the same question: what minimum ingredients transform matter into a living system? Indigenous perspectives offer unexpected insights for modern astrobiologists. The Cherokee story of the water beetle diving into the endless sea to bring up mud that expanded into land parallels the panspermia hypothesis, the idea that life's precursors might have hitchhiked on comets or meteorites. The Dogon's description of life emerging from a spiral of spirals aligns with the helical structure of DNA. Even the Buddhist concept of dependent origination, where nothing exists independently but only through interconnected causes, mirrors the systems biology view of life as networks of chemical reactions. These traditions didn't have microscopes or mass spectrometers, but they recognized a truth science now confirms. Life isn't a substance but a process, an intricate dance of relationships that blurs the line between organism and environment. Perhaps the most profound overlap lies in the shared emphasis on water. From the Kogi people's Great Mother, who births all life from her watery womb, to the Japanese Shinto belief that kami spirits inhabit waterfalls and springs, ancient cultures universally linked liquidity with vitality. Modern astrobiology's mantra, "Follow the water," proves just as sacred. Europa's subsurface ocean and Enceladus's icy plumes captivate us because water's unique properties, its solvent power, its hydrogen bonds, make it the universe's best candidate for fostering life. When the Navajo speak of To'i'ina, water as life itself, they're articulating what planetary scientists quantify when studying Martian gullies or Titan's methane lakes. This interplay between myth and molecule invites a radical thought. What if our ancestors' stories weren't just explanations but encoded observations? The Babylonian Enuma Elish describes the god Marduk using wind and lightning to animate mud, a sequence that suspiciously resembles electrochemical gradients across cell membranes. The Alaskan Inupiat tale of Sedna, whose severed fingers became seals and whales, evokes the evolutionary leap from single-celled to multicellular life. These narratives may not be literal accounts, but they preserve intuitive understandings of life's fragility, adaptability, and cosmic ubiquity. As we scan exoplanet atmospheres for biosignatures or drill into Antarctic ice for extremophiles, we're continuing humanity's oldest quest, not just to find life, but to understand our place in a universe that seems determined to wake up. The answer, it seems, has been written in our myths all along. Life isn't an accident but an inevitability, whispered in the chemistry of stars and the memory of clay. 5,000 years ago, the shadow of an Egyptian obelisk crawling across the sand wasn't just a marker of hours, it was a sacred covenant between earth and sky. These towering stone sundials, some reaching 70 feet high, divided daylight into 12 equal parts, their precision so reliable that modern reconstructions still track time within minutes of accuracy. But the genius lay in their adaptability. The length of these hours changed with the seasons, stretching in summer and shrinking in winter, mirroring the sun's own rhythms. Fast forward to today's atomic clocks, where a single cesium atom's vibration, 9,192,630,1770 oscillations per second, defines a second with unthinkable precision. What connects these two technologies across millennia isn't just the pursuit of accuracy, but a deeper, almost spiritual recognition. Time isn't just something we measure, it's how we commune with the cosmos itself. The Mayans took this celestial conversation even further. Their long count calendar didn't just track days but wove together overlapping cycles. The 260-day Tzolk'in for rituals, the 365-day Hob for agriculture, and the vast Biaktun cycles spanning thousands of years. When their astronomers calculated Venus's appearances to within 2 hours over a 500-year period, they weren't merely making observations, they were mapping time as a living tapestry, where planetary alignments dictated everything from coronations to crop rotations. Their Dresden Codex contains eclipse tables predicting lunar events centuries in advance, proving their grasp of time's fractal nature. Contrast this with today's pulsar-based timekeeping, where astronomers use the regular flashes of spinning neutron stars as cosmic metronomes. The tools have changed, but the principle remains. Time is written in the stars, yet the real revolution came when humanity untethered time from the heavens. The medieval water clocks of Baghdad's House of Wisdom, powered by regulated mercury flow, allowed timekeeping at night or indoors, a radical break from solar dependency. Then came the mechanical clock's ticking heart in 14th century Europe, its escapement mechanism transforming continuous motion into measured beats. This wasn't just technological progress, it was a philosophical shift. Time became something humans could compartmentalize, sell, and standardize, leading directly to railway time zones and eventually the global synchronization of GPS satellites. But here's the irony: our most advanced timekeepers have circled back to celestial principles. Atomic clocks aboard satellites must account for relativity. Time slows slightly in Earth's orbit compared to the surface, proving Einstein's revelation that time and space are woven together just as the ancients imagined. Perhaps no invention bridges ancient and modern like the Antikythera mechanism. Recovered from a 2,000-year-old shipwreck, this bronze gearwork computer could predict eclipses and track Olympic cycles with jaw-dropping accuracy. Its differential gears, a technology Europe wouldn't reinvent for another 1,500 years, modeled the irregular motions of the moon with epicycles, a mechanical echo of quantum physicists' equations today. The device even included a dial tracking the 4-year Callippic cycle, proving its creators saw time as multi-layered, just as we now understand it through relativity's lens, mutable, elastic, and deeply intertwined with gravity. This journey from shadow lengths to atomic oscillations reveals a profound truth about our species. Whether chiseling calendars into stone or counting cesium transitions in vacuum chambers, we're not just measuring time, we're seeking to understand our place within it. The next time you check your phone's clock, remember, that digital display carries the legacy of obelisks and water clocks, of Mayan astronomers and medieval monks, all asking the same essential question: not just what time it is, but what time means in the grand, unfolding story of the universe. In the quiet pre-dawn of a Polynesian village, a chant begins low and rhythmic, swelling like the tide. The words speak of Tipo, the infinite darkness before creation, and of Tain, the Sky Father, who pushed the heavens upward with his bare hands to make space for light. What sounds like myth holds a startling secret. These chants describe cosmic inflation with eerie precision, that fleeting moment when our universe expanded faster than light itself in the first fractions of a second after the Big Bang. Modern astrophysics calculates this inflationary period using quantum field theory, but the Polynesian oral tradition encoded it in metaphor, a world stretched into existence like bark cloth on a frame, thin and vast. The Cumulipo, Hawaii's sacred creation chant, takes this further. Its opening lines count generations of cosmic ancestors in pairs, mirroring the particle-antiparticle pairs that flickered into existence during inflation. When the chant describes the slime that established the Earth, it parallels how quantum fluctuations during rapid expansion seeded all future galaxies. Even the Maori concept of Tikor, the void of potential, aligns with physicist Andre Lin's chaotic inflation theory, where universes eternally bud off from a quantum foam. These aren't vague similarities, they're sophisticated models of creation, passed down through performance rather than equations. Compare this to the Hindu Rigveda's Nasadiya Sukta, which contemplates a time before time. There was neither non-existence nor existence then. That one breathed breathless by its own impulse. The phrasing mirrors inflationary cosmology's description of a false vacuum state, a self-sustaining energy field that required no external cause to begin expanding. The chant's climax, where cosmic heat toppers gives rise to order, could be a poetic rendering of reheating, the process where inflation's energy transformed into the hot soup of particles we call the Big Bang. What's extraordinary is how these traditions bypassed the need for advanced mathematics. The Aboriginal Australian songlines, for instance, map creation as a series of rhythmic footsteps across the land, a concept that finds resonance in inflation's quantum jitter, where microscopic ripples became the blueprints for galaxy clusters. The Navajo night chant describes the universe unfolding like a woven blanket, its patterns emerging symmetrically from a central point, much like inflationary bubble universes in string theory. These cultures didn't just guess at cosmic origins, they intuited them through observation and metaphor, encoding millennia of sky watching into oral formulae designed to survive generations. Modern science confirms their intuitions in spectacular fashion. The cosmic microwave background, the afterglow of inflation, shows temperature variations matching the density fluctuations described in the Maori chant of Rangi and Papa, where light and dark patches formed as the sky and Earth separated. When physicists simulate inflation's gravitational waves, their spiraling patterns resemble the Maori koru design, a curling fern frond symbolizing perpetual motion. Even the Polynesian concept of mana, an invisible force permeating all things, parallels the inflationary field's omnipresent energy, which left its imprint on the large-scale structure of the cosmos. This convergence raises a provocative question. Did ancient cultures preserve fragmented memories of cosmological events witnessed by earlier civilizations, or does the human mind naturally arrive at certain truths when contemplating creation? The Dogon's knowledge of Sirius B and the Maya's precise eclipse cycles suggest some traditions encoded empirical data. Yet the widespread themes of stretching, pairing, and emergent order hint at something deeper, a shared cognitive framework for processing cosmic scale. Just as children independently invent similar imaginary worlds, disparate cultures seem to have converged on comparable creation metaphors when faced with the universe's grandeur. The real lesson lies in how these traditions complement rather than contradict modern science, where equations describe the how, chants explore the why, the emotional weight of existence emerging from nothingness. Next time you hear the Hubble constant's value or see simulations of inflationary bubbles, remember, the same cosmic story lives in the Haka stomping feet, the Navajo dry paintings, and the Vedic hymns' vibrating syllables. The universe's first moments weren't just a physics problem, they were a performance, one we're still learning to witness in full. When NASA named its ambitious lunar program Artemis, it wasn't just picking a label, it was resurrecting a 3,000-year-old celestial dialogue. Artemis, the Greek goddess of the moon and twin sister to Apollo, now lends her name to the spacecraft that will carry the first woman and next man to the lunar surface. But this isn't mere nostalgia, it's a deliberate nod to the enduring power of myth. The original Apollo missions borrowed their identity from the god of light and reason, framing the moon landings as a triumph of human intellect. Artemis, by contrast, embodies wilderness, intuition, and the protector of young life, a subtle shift in narrative that mirrors modern space exploration's expanding priorities, from pure conquest to sustainable presence and even the potential for lunar childbirth. The tradition runs deeper than nomenclature. Every component of the Artemis mission whispers ancient stories. The Orion spacecraft, named after the legendary hunter placed among the stars by Zeus, will dock with the Gateway, a lunar outpost whose very concept echoes mythical way stations like the Norse Bifrost Bridge. Even the program's mascot, a sleek silver figurine named Camilla, after the warrior maiden from Roman lore, ties spaceflight to archetypes older than written language. This interplay isn't accidental. Psychologists recognize that archetypal narratives lower public resistance to ambitious technologies by making them feel familiar. When SpaceX's Falcon Heavy launched a Tesla Roadster toward Mars orbit with a space-suited starman at the wheel, the image wasn't just viral marketing, it was a conscious invocation of the cosmic hero's journey from Icarus to Interstellar. Look further back and the pattern intensifies. The Viking landers of the 1970s didn't just honor Scandinavian seafarers in name. Their mission patches featured a dragon ship sailing through the stars, directly linking medieval exploration to interplanetary discovery. The Cassini-Huygens probe to Saturn carried a plaque with verses from the Rig Veda, celebrating the moment when the universe was new. Even the Mars rover's Spirit and Opportunity drew their names from schoolchildren's essays invoking mythological themes of perseverance against cosmic odds. These choices reveal a seldom discussed truth. Space agencies don't just borrow from mythology, they actively participate in it, updating ancient tropes for the scientific age. The most fascinating examples emerge when engineers and storytellers collaborate directly. The European Space Agency's Bepi Colombo mission to Mercury takes its name from Giuseppe Colombo, a mathematician who solved the planet's orbital mysteries. But Bepi is also the Venetian nickname for Joseph, weaving personal history into cosmic exploration. China's Chang lunar probes reference a moon goddess who consumed immortality elixir, while their lunar rover U2, the Jade Rabbit, continues the celestial companion's mythical journey. Even commercial ventures join the tradition. Jeff Bezos named his Blue Origin rocket's New Shepard after Alan Shepard, but the suborbital capsule's massive windows evoke the all-seeing eye of Horus from Egyptian cosmology. Why does this symbiosis persist? Because space travel, at its core, remains a storytelling enterprise. Mission planners understand that equations alone can't capture the public imagination, but a narrative spanning temple carvings and rocket gantries can. The Artemis program's logo, with its crescent moon and rainbow trajectory, deliberately mirrors ancient lunar goddess iconography found in Catalhuyuk murals and Cretan seals. When astronauts read Genesis or the Epic of Gilgamesh from orbit, they're not just sharing literature, they're performing a ritual as old as stargazing itself, using myth to bridge the known and the unfathomable. This tradition now extends beyond government programs. Private space flights, eccentric billionaires lean heavily into mythic imagery. Elon Musk's Starship prototypes, named after science fiction vessels. Richard Branson's Virgin Galactic evoking celestial virgin goddesses. The difference lies in self-awareness. Where NASA uses mythology to solemnize, commercial entities often weaponize its nostalgia. Yet both approaches confirm mythology's undiminished power to frame humanity's relationship with the cosmos. Perhaps the ultimate testament to this continuity came in 2019, when the Israeli Bereshit lander crashed on the moon carrying a lunar library etched with human knowledge, including centuries of mythological texts. In that moment, the moon became what ancient cultures always imagined, a repository of stories where Ovid's Metamorphoses and Navajo sky legends now literally share space with engineering schematics. The next time Artemis's Orion capsule orbits the moon, it won't just be following orbital mechanics, it'll be tracing the same symbolic path that lunar deities walked in our collective imagination since the first campfire tales were told under starry skies. Stonehenge's towering sarsen stand silent on England's Salisbury Plain, their purpose debated for centuries until archaeologists with laser scanners and 3D modeling revealed something extraordinary. Those massive stones aren't just arranged for ceremony, they're a precision astronomical instrument. During the summer solstice, sunlight pierces the heel stone to strike the altar dead center, while winter solstice sunsets align perfectly with the slaughter stone's grooves. But it's not just about solar events. Recent LIDAR surveys show the surrounding landscape is dotted with burial mounds positioned to mark lunar standstills, the moon's most extreme northerly and southerly risings, which occur only every 18.6 years. This wasn't random, it was a celestial calendar carved in stone, blending spiritual reverence with scientific observation. High in the Andes, Machu Picchu's Intihuatana stone tells a similar story. Long dismissed as a mere ritual object, this granite pillar's true function emerged when researchers tracked shadows across its carved angles. At noon during the equinoxes, the stone casts no shadow at all, its edges aligning perfectly with the sun's zenith passage, a phenomenon unique to tropical latitudes. The nearby Temple of the Sun features windows that frame the Pleiades' heliacal rising, signaling the Inca planting season. Even the city's urban layout mirrors the constellations. The sacred district's buildings align with the Milky Way's dark cloud constellations, which the Inca saw as celestial animals guiding agricultural cycles. These aren't coincidences but proof of a civilization that wove astronomy into every stone. What's revolutionary about modern archaeoastronomy isn't just discovering these alignments, it's decoding the worldview behind them. Take Choco Canyon's Sun Dagger, where ancestral Pueblones carved spiral petroglyphs that interact with sunlight. At summer solstice, a blade of light bisects the spiral. At winter solstice, two daggers bracket it. But the real marvel comes during the lunar standstill, when moonlight repeats the solar pattern with eerie precision. This wasn't just a calendar, it was a cosmological model, demonstrating how the sun and moon shared sacred symmetry. Similarly, Egypt's Karnak temple axis doesn't just point to the winter solstice sunrise, it mirrors the Nile's flooding schedule, linking celestial events to terrestrial survival. The deeper we look, the clearer it becomes. Ancient architects didn't just observe the heavens, they replicated their rhythms on Earth. The methods behind these discoveries are as fascinating as the findings themselves. At Newgrange in Ireland, a team used photogrammetry to reconstruct the passage tomb's original entrance, revealing how its roof box channels sunlight into the chamber for 17 minutes at winter solstice dawn, an effect invisible since silt obscured it centuries ago. In Mexico, archaeologists employing drone-mounted magnetometers discovered buried Olmec structures aligned with Venus's 8-year cycle, proving Mesoamerican sky watching predates the Maya by millennia. Even traditional knowledge plays a role. Polynesian navigators recently helped researchers identify star compass-married temples on Tahiti, where stone pillars mark celestial bearings for open ocean voyaging. This interdisciplinary approach is rewriting history. The 200-year-old Nebra sky disk, once considered a Bronze Age anomaly, now makes sense when viewed alongside German solar observatories like Goseck Circle. Both use golden arcs to track solar azimuths between solstices. Similarly, Cambodia's Angkor Wat, long studied for its Hindu iconography, reveals its true genius when viewed from space. Its moats and towers mirror Draco's stars during the spring equinox of the temple's construction era. The lesson is clear: separating science from religion in ancient sites misses the point. These monuments were both spaces where the sacred and empirical intertwined, where measuring time was an act of devotion and tracking stars a form of prayer. As laser scans uncover new alignments and oral traditions provide missing context, one truth emerges: our ancestors didn't just build beneath the sky, they built because of it. Whether it's the way Mnajdra Temple's Malta's limestone slabs frame the equinox sunrise, or how Zimbabwe's great enclosure walls align with Sirius's heliacal rising, these structures whisper a shared human impulse. The cosmos wasn't just overhead, it was the blueprint, the clock, and the scripture, all etched in stone waiting for us to rediscover. Neuroscience reveals something extraordinary. The human brain might be hardwired to perceive the cosmos in ways that blur the line between science and spirituality. Consider the near-death experience reports that surface across cultures. People clinically dead before revival often describe floating through dark tunnels toward radiant light, their consciousness expanding as if merging with infinity. Strangely, these accounts bear uncanny resemblance to what physicists simulate when visualizing a black hole's event horizon. The intense gravitational pull would warp light into a tunnel-like funnel, with relativistic effects distorting time into something fluid and dreamlike. Are these shared visions mere coincidence, or does the brain's architecture generate universal metaphors when pushed to its limits? Meditation research deepens the mystery. Advanced practitioners, from Tibetan monks to astronauts practicing mindfulness in orbit, report strikingly similar shifts in perception. A dissolution of ego, an overwhelming sense of unity with existence, and the vivid sensation of the body dissolving into starlight. Astronauts call it the overview effect, a cognitive shift triggered by seeing Earth from space. Brain scans during deep meditation show decreased activity in the parietal lobe, the region responsible for spatial orientation and self-boundaries. When this area quiets, the sense of separation collapses, much like the quantum entanglement linking particles across vast distances. It's as if the brain, stripped of its usual reference points, defaults to a primal understanding of interconnectedness that mirrors modern physics' most radical theories. The parallels extend to our neural architecture. The brain's default mode, network active during daydreaming and introspection, produces patterns resembling cosmic webs when mapped by fMRI. Indigenous cultures describing the universe as a great web or tree of life might have been intuiting structures science now confirms, from the neural synapses firing in our heads to the filamentary structures connecting galaxies. Even the brain's reliance on harmonic oscillations, theta waves syncing with Earth's Schumann resonances, gamma waves mirroring pulsar frequencies, hints at a deeper resonance between microcosm and macrocosm. But here's the provocative question: are these similarities evidence of a fundamental truth, or is the brain simply recycling familiar patterns to comprehend the incomprehensible? Cognitive scientists point to apophenia, our tendency to perceive meaningful connections in randomness, yet the consistency of these experiences across time and culture challenges easy dismissal. The Mandelbrot set's fractal geometry appears in neuron branches, river deltas, and galaxy clusters alike. Perhaps the brain doesn't just interpret the cosmos, it reflects its very blueprint, a living fragment of the universe contemplating itself. When mystics speak of as above, so below, they might have been closer to quantum biology than they ever imagined. This interplay between perception and reality reshapes how we understand ancient cosmologies. The Hindu concept of Akasha, a subtle, all-pervading medium, finds echoes in today's quantum field theory. Buddhist descriptions of reality as interdependent arising align with ecological and cosmic networks where nothing exists in isolation. Even the Aboriginal songlines, which map knowledge onto landscapes, mirror the brain's method of encoding memory through spatial relationships. The recurring motifs aren't just poetic, they're cognitive maps, suggesting that the human mind and the universe share a common language of patterns, rhythms, and connections waiting to be decoded. Ultimately, these neural cosmic echoes invite us to reconsider the boundaries of consciousness itself. If a meditating monk's brain and an astronaut's vision of Earth can produce identical states of awe, what does that say about our place in the cosmos? The answers might lie in the very wiring of our minds, where science and myth converge, not as opposites but as complementary lenses revealing different facets of the same infinite mystery. Artificial intelligence sifts through petabytes of telescope data at speeds no human could match, detecting exoplanet transits, classifying galaxy shapes, even predicting supernovae before they brighten our skies. Yet in this relentless analysis, something unexpected emerges. Machine learning models sometimes flag celestial patterns that eerily echo ancient star lore. When Google's AI identified a hexagonal storm pattern on Saturn, a shape the ancient Greeks associated with Kronos, the god of time, it revived a 2,000-year-old symbolic connection between the ringed planet and temporal cycles. Similarly, neural networks mapping dark matter's cosmic web produce filamentary structures resembling Yggdrasil, the Norse world tree whose roots and branches connected 9 realms. These aren't just visual coincidences, they hint at a provocative possibility. Could AI, in its quest for objective patterns, inadvertently rediscover the symbolic language early cultures used to make sense of the stars? The process reveals deeper layers when examining how algorithms classify astronomical phenomena. Take NASA efforts to train AI on solar storm data. The system began associating coronal mass ejections with dragon-shaped curves in plasma flows, mirroring how Chinese astronomers once depicted these eruptions as celestial dragons battling the sun. The machine didn't know the myth. It simply identified the most efficient way to categorize the phenomenon's visual signature. This parallel cognition suggests that both human intuition and artificial neural nets gravitate toward similar archetypes when interpreting cosmic chaos. After all, before telescopes, people navigated by memorizing star patterns as animals, heroes, and gods, essentially creating mental algorithms for celestial wayfinding. Modern AI does the same, just with convolutional filters instead of campfire stories. But the real frontier lies in generative AI's potential to forge entirely new mythologies. When researchers at Caltech fed star formation simulations into a GPT-style model and asked it to narrate the process, the system spontaneously generated tales of stellar nurseries, where young stars competed for cosmic dust, language strikingly similar to Polynesian creation chants describing stars as offspring of the Sky Father and Earth Mother. More startling was Project Panops at the University of Cambridge, where an AI trained on global folklore began linking gamma-ray burst distributions to archetypal, hero's journey narratives without being prompted. The implication is profound. There may be inherent narrative structures woven into the universe's phenomena that both human storytellers and machine learning models independently detect. This convergence raises ethical and philosophical questions. If an AI identifies a supermassive black hole's accretion disk as a cosmic serpent, as one Zurich-based project reported, does that validate indigenous descriptions of black holes as devouring entities, or is it merely algorithmic pareidolia seeing shapes in randomness? The Dogon people's knowledge of Sirius B complicates this further. Their oral traditions contained precise astronomical details that seemed impossible without telescopes. Now, as AI detects similar, intuitive patterns like correlating planetary alignments with historical seismic events, much like the Maya did, we must ask whether these systems are uncovering lost knowledge or creating persuasive fictions from data noise. Perhaps the most intriguing experiment comes from the SETI Institute, where machine learning models analyze radio signals not just for mathematical patterns but for mythic resonance. Early tests show that when signals contain certain repeating ratios, AIs tend to generate creation myths involving twins or cyclical rebirth motifs found in everything from Greek cosmology to Navajo emergence stories. This suggests that if extraterrestrial intelligence ever communicates with us, their message might align with narrative structures already embedded in human mythology, filtered through the universal grammar of mathematics. As AI becomes astronomy's indispensable partner, it does more than crunch numbers. It reflects back our oldest impulse to clothe the cosmos in meaning. The algorithms don't just process data, they continue humanity's eternal project of spinning stars into stories. Whether decoding petroglyphs as ancient star charts or generating new legends from quasar distributions, these systems remind us that science and myth aren't opposites. They're twin lenses for beholding a universe that speaks in equations and epics alike. The story of Prometheus stealing fire from the gods and gifting it to humanity is more than just a myth. It's a cautionary tale about the double-edged sword of progress. As we stand on the brink of becoming an interplanetary species, the ethical dilemmas surrounding Mars colonization echo this ancient paradox. On one hand, the drive to explore and settle new worlds embodies humanity's boundless curiosity, the same impulse that led us to harness fire. Yet, like Prometheus, we risk unintended consequences, altering pristine Martian ecosystems before we fully understand them, or repeating Earth's history of exploitation on a cosmic scale. The indigenous peoples of the Americas and Australia have long warned of the dangers of disrupting sacred landscapes, stories that now take on new urgency as we contemplate terraforming another planet. Consider the parallels between Prometheus's punishment chained to a rock as eagles tore at his liver and the potential fallout of reckless expansion. SpaceX's vision of a self-sustaining Martian city could become a modern Icarus tale if life support systems fail, leaving colonists stranded in a hostile environment. The Greek fates, who measured each thread of life, remind us that every technological leap carries moral weight. Should we prioritize scientific discovery over planetary preservation? The Navajo concept of haja, or walking in harmony with nature, offers an alternative framework, one where exploration doesn't mean conquest but stewardship. The ethical tensions intensify when we examine who gets to decide Mars's future. Will it become a playground for billionaires, a research outpost for governments, or a shared heritage for all humanity? The Babylonian myth of the Anunnaki gods dividing the heavens among themselves mirrors today's debates over space treaties and resource extraction rights. Meanwhile, the Polynesian voyagers' tradition of Imin Tuki, singing to calm the ocean before long journeys, suggests a model for approaching alien worlds with humility rather than dominance. Perhaps the most profound lesson comes from the Hindu tale of the churning of the ocean, where gods and demons cooperated to extract the nectar of immortality, only to nearly destroy the cosmos in the process. As we drill into Martian ice caps and test atmospheric generators, we're engaging in our own cosmic churn with stakes just as high. The difference is, this time we have the wisdom of centuries of cautionary tales whispering in our ears if only we choose to listen. The fire we're stealing now isn't just flames, it's the very spark of creation itself, and how we wield it will define not just our future on Mars, but our legacy as a species. The first photograph of a black hole, a fiery ring framing abyssal darkness, already feels like something ripped from ancient prophecy. That luminous halo, captured by the Event Horizon Telescope in 2019, didn't just confirm Einstein's equations, it birthed a new celestial archetype. Future civilizations might speak of this image the way we recount the myth of Persephone's descent, a threshold between realms where light bends eternally toward the unseen. Imagine the stories that could emerge when we finally record a black hole's scream, the gravitational waves emitted as it consumes a star. Oral traditions might describe it as the wail of a cosmic leviathan, or a siren song luring matter to its doom, echoing the Greek sailors drawn to their destruction by irresistible voices. Warp drive experiments could spawn even richer legends. If humanity ever crumples space-time into an Alcubierre bubble, theoretical physicist Miguel Alcubierre's concept for faster-than-light travel, the experience might inspire myths as vivid as Odysseus tied to the mast. Passengers inside such a vessel would witness stars ahead, blue shifting into oblivion while those behind red shift into darkness, space itself warping like the world tree Yggdrasil bending in a storm. Future generations could speak of the Great Fold, when travelers stepped between stars as easily as pulling 2 points on a cloth together. This wouldn't just be technology, it would be alchemy, transforming the leaden constraints of relativity into the gold of interstellar access. Consider how gravitational lensing, the bending of light around massive objects, might evolve into folklore. Telescopes using the sun as a lens could one day image exoplanets in staggering detail, effectively creating cosmic scrying mirrors. Cultures might ritualize these observations, interpreting atmospheric swirls on distant worlds as messages from ancestral spirits or omens of future events. The practice could mirror the Babylonian astrologers who read destinies in planetary motions, except now the celestial text would be clouds swirling over alien continents. Even failed experiments could enter mythology. A warp drive prototype that destabilizes catastrophically might become this era's Icarus tale, warning against overreach. The Kuiper Belt's icy bodies, reshaped by future mining, could feature in stories like the Navajo, Coyote, and the Stars, where mischievous figures rearrange the heavens. And what of quantum communication networks linking Earth to Mars? Their instantaneous connections across millions of miles might revive ancient beliefs in sympathetic magic, the idea that actions on one object affect another at a distance, now validated by entanglement. The most profound myths may arise from discoveries we can't yet foresee. Just as medieval Europeans couldn't have imagined pulsars spinning neutron stars whose rhythmic pulses they'd likely have interpreted as divine signals, we too will encounter phenomena that defy current frameworks. Perhaps we'll find megastructures built by alien civilizations, sparking creation stories where humanity is the younger sibling in a cosmic family, or detect signatures of higher dimensions, inspiring myths as layered as the Hindu cosmology's 14 worlds. What unites all these potential narratives is their roots in wonder. Whether it's a child hearing about black holes for the first time or an astronaut witnessing space-time ripple during a warp jump, the human response remains the same: to weave explanation and awe into story. The equations will remain vital, but it's the tales of heroes sailing folded space, of explorers outwitting event horizons, of entire worlds born from a quantum fluctuations whisper, that will carry these truths across generations. Science gives us the stars, myth teaches us how to sing them. From the moment Babylonian astronomers pressed wedge-shaped marks into clay tablets tracking Venus's dance across the sky, to the James Webb Space Telescope capturing starlight from the universe's first dawn, one thread connects us across millennia, not just the hunger to understand the cosmos, but the need to feel it. Science measures wavelengths and calculates gravitational forces, but myth gives those numbers meaning, turning supernovae into dragons and quantum foam into the breath of creation. The two aren't rivals, they're collaborators. When the Hubble Deep Field revealed thousands of galaxies in a patch of sky no bigger than a grain of sand held at arm's length, it didn't invalidate the Navajo teaching that each star is a sacred fire. It expanded it, showing just how vast that sacredness truly stretches. Consider how modern cosmology mirrors ancient intuitions. The Big Bang Theory describes a universe exploding from infinite density, a concept that would have made perfect sense to the Maori storytellers who spoke of Tikor, the nothingness that birthed all things. Dark matter's invisible scaffolding holding galaxies together echoes the Hindu concept of Indra's net, where jewels reflect each other across a web no one can see. Even the multiverse hypothesis finds its precursor in the Buddhist idea of infinite world systems, each with its own Buddha. These parallels don't mean our ancestors had telescopes or particle accelerators. They mean something more profound. The human mind, whether guided by equations or allegory, keeps stumbling toward the same truths about reality's flexible, interconnected nature. What's changed isn't the essence of our questions, but the tools we use to answer them. The Babylonians used abacus-like devices to predict eclipses. We deploy AI to map dark energy. The Dogon people memorized Sirius B's 50-year orbit through oral tradition. NASA Voyager probes carry that same star's coordinates on golden records. The methods evolve, but the mission remains to decode the universe's whispers, whether they're etched in cuneiform or binary. And just as the ancient Greeks saw Orion not just as stars but as a hunter mid-stride, our telescopes now reveal the Orion Nebula's stellar nurseries, where new suns are born in glowing gas clouds. The story didn't end, it got richer. This brings us to the heart of the matter. Science doesn't kill wonder, it reframes it. The more we learn about black holes or quantum entanglement, the more mysterious the cosmos becomes. Maybe that's why the old legends endure. They remind us that curiosity isn't just about answers, it's about learning how to ask better questions. So the next time you look up at the night sky, try seeing it through both lenses, the astronomer's precise calculations and the storyteller's boundless imagination. After all, the universe doesn't care how we understand it, only that we never stop trying. Now we'd love to hear from you. Which ancient cosmic legend feels most alive in today's science? Is it the Dogon Sirius mysteries, the Maya's fractal calendars, or something else entirely? Drop your thoughts below, and if you've enjoyed this journey through time and space, hit subscribe. There are always new horizons where science and myth collide, and we're just getting started. See you in the next adventure.